Amanda and her friend love Fruity Chews. They come in packets of 12, and the manufacturer claims each Fruity Chew is equally likely to be orange, raspberry, lemon, lime, or passion fruit flavored. Okay, what we're going to do is we're just doing page 53 of the distributions book just to look at how we could do binomial. Okay, so with binomial there are two parameters. So when you're looking at questions, you're looking out for two parameters. And these two parameters are seen here. They come in packets of 12. So you buy your pack of Fruity Chews, right? And inside of, oh, that doesn't fit in the screen at all. Right, inside of this pack is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 Fruity Chews, right? And so that's our first thing. N equals 12. Right? Now, the manufacturer claims that they are equally likely to be, so we've got orange, raspberry, lemon, lime, and passion fruit. So we can also see if they're equally likely, they all have a 1 in 5 chance of happening. So we've now got a probability, right? So now we know that this is a binomial distribution question. So let's have a look at it. Okay, what is the theoretical probability that a packet contains no orange flavored chews? So they've now just assigned to us what a success is. So we know that n equals 12, but we've also got a probability, and now this is our success. They've just told us what our success is going to be, and the probability of an orange flavored one is, I'm just going to do it here, P equals 1 out of 5, because that's 1/5 of the flavors and are equally likely. So no orange flavored means that probability that X takes on the value 0. So we've got this, this, and that. Now we could use the formula sheet like this and go and put in our N and our probability and use this, but to be honest, I cannot be bothered. You could also use the formula. We have a calculator to do these sort of things. So we can just go to our calculator. We're going to go menu. We're going to go into statistics, distributions. We're looking at binomial. We are looking at a point, our point being 0. So we're going to go BPD. And so X equals 0. Numetrial is 12. There are 12 fruit chews, and the probability of each one being orange is 1 out of 5. Okay, so there's the probabilities. Pretty straightforward. Equals 0.0687. Alright, let's move on. What is the theoretical probability that a packet contains fewer than 4 orange? See, that's the same success. Same probability, same numetrial. But we're now looking at fewer than 4. Fewer than 4. So Px is less than 4. Now remember, when we're doing cumulative, our calculator is only capable of doing Px's less than or equal to something. So how are we going to change that to being less than or equal to? So what you can do is you can think of a list of all of them. So what numbers are less than 4? Well, 0, 1, 2, and 3. This is a discrete distribution, so these are the options. So this, how do we write that in a probability statement? Well, that's just 3 or less. So probability is X is less than or equal to 3. Okay, so we're going to just go back to distribution, binomial. This time we're looking at cumulative, and we're looking at up until the number 3. Same N, same P. Okay, 0.7946. Okay, next one. Calculate the mean and standard deviation for the number of orange flavored chews in each packet. Okay, whenever you have a standard deviation question, it means you can just go to the formula sheet. Any mean or standard deviation problem, you can just take it to the formula sheet. So where am I going to put that? I'm going to put that down here. Calculator up here. Okay, So we're going to start with mean. So down here we've got a formula for mean. Mean is n times pi. Now just remember that they instead of writing p, they do pi. I don't know how that helps at all because pi is literally already a number in maths. So I don't like that they use pi as probability, but that's just how it is. Right, so we're going to go n, which is 12, times the probability, which is 0.2, and that gets us, is that right? Yeah, that's right. 12 times 2 is 24, so it's going to be 2.4. Does that make sense? Yeah, that makes sense. If I've got a packet of 12 of these chews, 2.5 of them being orange on average, it makes sense to me. Okay, so now what about the spread outedness, the standard deviation? So this time we're going to go, it's going to be a square root, so we're using this formula down here. So it's going to be a big old square root, and inside the square root we're going to go n, which is 12, times the probability, which is 0.2, times 1 minus the probability, which is 0.8. Right, so let's do that in our calculator. We'll go back to menu. So we're going to do a big old square root. I'm going to put a bracket because I want everything under that square root. 12 times 0.2 times 0.8, and then close that bracket off. 1.3. I mean, standard deviation is kind of hard to like logically think about. You can think about like how much difference do you expect in your packet of fruit chews? Is there big spread? And in this case, not really. You're sort of, you know when you buy like Skittles and you get heaps of yellow ones, you're like, that's not what you want to happen. You want there to be like an even distribution of each color. Actually, it'd be better if there were more purple ones, but you know, each their own. Some people must love yellow. Why else would they keep it? Okay, Amanda and Nigel buy a packet of fruity chews each. Calculate the theoretical probability that there is exactly one orange fruity chew in each packet. Ooh. So what's the probability of there being one fruity chew in this packet? So let's just p exactly 1. Px equals 1. That's a pretty straightforward probability for us to be able to calculate. I'm just going to change that number to 1. Oh yeah, it's like a 20% chance. 0.2061. Oh, no, that should be a 2. I bet. Don't worry, I can change it. That's a probability of it happening. But then Amanda buys one, and then Nigel goes ahead and buys one as well. And we want to know, this is one fruit chew, and this is one fruit chew. This makes the probability of that happening way lower, right? So, and we'll see that soon. So all you do when you're doing this is it's sort of like a probability tree. You've got Amanda's branches and then Nigel's branches, right? And it's her getting one and then him getting one. So normally what you do is you multiply the probability of each branch, and here it's around about 0.2. So it's just going to be that probability times that probability. But we're going to be a bit more accurate than 0.2. We'd probably get away with it in NCA, to be honest. 0.2062 times itself. But if we're lazy, instead of doing that, I'm going to do it first, just to give you the logic. That's the probability. So it's going to be 0.2062 squared. That's just a way of writing times itself. So you could do that in your calculator if you want to save some time. 0.0423, no, 25. Alright, so it's like a less than 5% chance of that happening. What is the theoretical probability that a packet contains at least 5 chews that are either, oh shucks, raspberry or passion fruit flavored? Okay, they flipped the success on us. Raspberry or passion fruit, this is our new success. So we've got new probability. So this to happen, raspberry or passion fruit, means we're going to add them. So 0.2 plus 0.2. This is our new probability. So let's do that. So in the distribution, it's going to be here. New probability is going to be 0.4. Now we're looking at least 5 chews. At least 5. P, X greater than or equal to 5. Our calculator can't do that. Our calculator can only do this way, less than or equal. So this is greater than or equal to 5. Let's just think of an example. That means 5, 6, 7, 8. How many chews are there? 12. 9, 10, 11, 12. Right? We want to know this one, so we're going to have to do the opposite. So the opposite of that would be 4, 3, 2, 1, 0. So how can we do that? Well, that's going to be P, X is less than or equal to 4. Because that means we're going to include everything but these. And then we'll just do 1 minus that, and then that will get us this list. Right? 1 minus. So we're going to go CD. We want to know 4. Our probability has changed to 0.4. So then it's going to be 1 minus 0.4382. And that's going to get us 0.5618. And that's our answer there. Okay, final one. Write down 4 reasons why you think the binomial distribution is appropriate for this situation. Remember, binomial, you got 2 fists. Fist, F-I-S-T. Write that down on your paper at the start of your exam. There are a fixed number of trials. Each is independent of the other. Whatever fruit you get here is independent of the fruit you get here, which is independent of the fruit chew you get here. Right, they're independent of each other. S, same probability. So each fruit chew is a 0.2, 0.2, 0.2, all the way down. T, 2 outcomes. For this situation, yeah, I don't like when these books do that. What situation? This situation with 1 over 5 talking about orange flavored, or this situation being raspberry or passion fruit? I have to assume it's for the question just before. Okay, so that means raspberry or passion fruit. So what we do is we just expand on these and just use these. Make sure you use these words. Right, so we start with this one. There are a fixed, see how we just use the word again, number of fruity chews, make it in context, in the packet. So you use, these are the buzzwords that you got to use, and then you just got to put it in context. Sometimes you got to do a little bit of thinking. Each, and remember that they're saying appropriate. Sometimes they want you to critique it, and then so you say mean things about it. Other times they want you to justify it. So we're justifying. We're saying this is perfect, a perfect model. So each lolly, each fruity chew will not affect what the others. Oh man, this is bad. This is a bad one. I've screwed this up because of bad English. What the others in the packet will be. Math stuff, and we only need 2 to get the merit. Same probability. Each. Oh, look at this. When they've given you this in context, equally likely. They've given you the answer here. Each fruity chew is equally, they've told you that, so you can use that information. Equally likely to take on each flavor. P equals 0.2. Oh, I should be talking about this one, but I don't give a crap. 2 outcomes. Okay, we're just going to use the one before. Raspberry plus passion fruit equals success. Other flavors equals failure. And that is all from me. That is page 53. Let me look at the answers. Perfect. We got 100% correct. Well done. GG.